Yeah. I just found a brand new box today. You look nice today. Madeline, if you leave your phone up there the entire time we do notes, come here and I'll stamp your paper. You can get bonus points on your homework. Good for you. Let's see. Michaela, can you remind us about the bathroom pass? Exactly. If you need to use the bathroom pass, no big deal. Just write your name and the time that you leave so we know about when the pass should be getting back. I also highly discourage you from using the bathroom pass while I am in the middle of lecturing, because then you miss out on stuff. But if you have to go, you have to go. Today, this is the last lesson of stuff that is going to be on your quiz. So it's graphing square root and cubic functions. We've been graphing things. The way that transformations move your graphs, same for everything. We mainly need to know basic shapes. So for the square root graph, guess what? You can kind of remember because it's kind of like a root. I mean, not exactly, but the shape of a square root graph is like that. So you can kind of maybe remember that a square root has the little radical and the square root shape is like that. Technically, a square root and a square, they're inverses. So really what it is it is half of a parabola. But the bottom half doesn't show up or else it wouldn't be a function. So the shape is half of a parabola. So it's like half of a U turned on its side. So this would be the shape of a parabola turned on its side, but it can only be half to make a function. A cubic function. Cubic function. Let me ask you this really quick. If it is to the third power, is that an even or an odd function? Odd. So the two sides of your graph, are they going to go in the same direction or opposite? So when you make a cubic function, a cubic is like a line in that a positive line would go like this. A positive cubic is just curved. So it's like a line in that it's got one side going up, one side going down, but it is like that. It's a cubic. Odd, so opposite ends. Whether you are a square root or a cubic function, where is your graph, your parent function? Like no shifts, no transformations. Where is it going to start? Where is the middle? 0 in the middle at the origin, and that's at 0. For either one, it's going to be right in the middle at 0. From there, we need to think about what we are doing to the x. For a square root function, we are square rooting it. We're square rooting it. So after 0, as you move to the left, so that's not to the left, to the right, really only things that are perfect squares are going to give us nice, pretty integers. So if I move over to 1, what's the square root of 1? 1. So I can go up to 1 and I can put a point. If I go over to 2, is 2 a pretty square root? What about 3? Square root of 3. What about square root of 4? 2. So you can go over to 4 and up to 2. Which one would be the next pretty square root? No. 9. 9 would be the next pretty square root. And it's not actually on our graph because it stops at 7. But it would be like here-ish. So you see that if we connect those dots, it's kind of going to make a curve. So it is like half of a U. And that's my graph. Can we take the square root of negative numbers? What do they make? Imaginary. So that's why we don't go backwards. So it doesn't live over here. It starts here. For my cubic, I got to think about what am I doing to the x? Well, I'm cubing it. So if I go over to 1, what's 1 times 1 times 1? Just 1. So you go over 1 and then up 1. What is 2 times 2 times 2? 8. Very good. So I would go over 2 and then up 8. Well, it stops at 7. So I'm just going to go up a little bit more. It's maybe like at the top of the point. Now I know that basic shape looks like this. It's like a U that gets split in half and one half gets brought down. So it's going to have symmetry. It moves just in the diagonal opposite direction. So we can go to the left 1 and down 1, to the left 2 and down 8 to make that shape. So when I connect the dots, I need to remember that it is like a U that got broken and turned the other direction. So it needs to be as curvy as possible. So I curve and go up, and I curve and go down. Especially with both of these graphs, sometimes it's hard to get more than 2 points on there. So you just have to be careful as you connect your dots. So when you're making a cubic function, just remember that if that next dot is off the graph, then you can't cross that line. Like you have to still stay in that line. You can't cross the next one. Moving on, transformations. We've been doing transformations. How your graph moves is exactly the same. Different parts do the same thing. So when you're looking at a square root versus a cubic, okay, we've still got the x part and it's in parentheses. What you're doing to the x for a square root is that you're square rooting the x part. For a cubic, you're cubing the x part. That's the only thing that changes. You still have something in front of the x in both of them. You have something inside the parentheses for both of them. And then you have something after that operation, whatever's happening to the x. Same place. And what they do is the same. So the A is the only one that can do 2 different things. Does anybody remember what A can do? It can tell you if you're positive or negative. Yes, absolutely. So it can tell you about reflections. So if it's positive or negative, and that would make it reflect over X. The other thing that it can do, anybody remember what else A can do? It can kind of, what do you think? Not really. It can tell you your speed, so it can stretch you or compress you vertically. So it can be a stretch or compression vertically. So a stretch would make your graph longer this way. A compression means that it gets pushed smaller. So A can do two things. It can reflect or make you positive or negative, that right side of your graph. Or it can stretch or compress you vertically. H. What happens with anything in the X grouping? How does that move you? Left or right in an opposite direction. So left or right, but opposite. So it moves opposite because in the formula, it's a negative. It's left or right, has a T, left or right. Then it moves in an opposite direction than it shows in the equation. What about K? How does K move me? Up or down? What you see is what you get. So it's up when it's positive or down when it's negative. H and K. So remember, H and K creates a point, and you can find the point from looking at the equation. For a square root, it tells you where you start. So H and K is that starting point for a square root. And for a cubic function, it's the center. So you can figure out either your center or your starting point from that HK, which is in your equation. Basically, it's just telling you where you're moving your start. You're moving it left, right, or up or down, and that's where you put your starting point. So let's do some practice. The first few problems, it's just asking you to identify or describe transformations. So a couple of things that I want you guys to do first, because it's mixed. It has square roots and it has cubics on your test or on your homework. So first thing I want you to do is be able to just identify what that shape looks like. And so remember that when you're looking at the square roots, that you can just identify that it's going to have this shape. Unless maybe you notice this one is negative. So a negative square root is going to go down. That one's negative. The next one is a negative cubic. So instead of pointing up at the end, you point down. The last one is positive, so it's going to face up. So that is certainly a way that you can start describing transformations, is by just identifying that shape. You're either a cubic or you're a square root. Now we can go through and we can look at other things. Next thing that I want to do is identify that point right here. So for this first one, we have a -3 and a +1, except for everything underneath that square root, it's opposite. So my HK, that point right there, it's going to be +3, 1. For B, what's that point going to be? -2, -4. There's nothing in the X grouping for C. So it starts out as 0, 1. And for the last one, what should it be? 1, -3. So we know where we're starting our graph. That's another way you can describe it, is being able to show me this is what the graph looks like. This is where that point's going to be. Some other ways you might see it described, let's say it was a multiple. This is going to help you the most if you're going to graph it. The other part we got to check for is stuff that's out front. This one has a 2 out front, so that's going to stretch by 2. Nothing but the negative. The negative reflects, so that would be a reflect over X. Same thing with C, you reflect over X. And the very last one, there's a 3 out front, so 3 means stretch. If it's a fraction, if it's a 1/2, it means you compress or you get shorter. You get like squatty. We could also identify the other things. And looking at my point, that means that I'm going to go right 3 and then up 1. My second point says that I'm going to go left 2, down 4. I'm not going to say the other 2 out loud. I want to see if you can identify how the other 2 move you. So do you agree so far with just the descriptions? So there's a multiple choice question on your test. I give you an equation. I want you to tell me, find the answer choice that has the descriptions. So I'm hoping that we do that good. Are we good so far? Anybody still copying? All right, for question 2 or example 2, it says describe the transformations and write an equation. Well, first thing that we need to know is like what even equation we're going to make. So for E, what type of equation is that? Square root. So we know we're going to have a square root. What about F? Cubic. Good job. And the last one. Another square root. Oh, now I need to check. Are any of them positive or negative? G is a negative square root. So I'm going to give myself a note on that. Oh, yes. F is also negative. Good job. Yep, I'm pointing down. Now we're going to look for those transformations. So what will help us is if we identify where is that point. So what is my starting point for E? -3, 1. Okay, so that is going to help us make an equation. My equation, f of x equals, So I'm going to leave myself a little bit of space after the equal sign and put a square root. Underneath this square root, I have an x. So I have three places that I can put a number. So in front of the square root, is that reflected or stretched any? You can check for stretches by if you go over one, up one, that's not stretched. You would have to make a different movement first. If it was stretched, you would go over one and then up two or something. It would not be over one, up one. So nothing goes in front of the square root. Inside the square root, everything in the x grouping is opposite. So the x part of my starting point has to be +3. After the x grouping, that's k, and k is what you see is what you get. So +1. My second equation for f, what is my center point? 1, 2. So when I write my equation, this one is a negative, so negative has to go first. Then I'm gonna leave my little bit of space. I have my x grouping, and it's gonna be cubed. So in front of the x grouping, I'm reflected. That's why I've got a negative there. I can check to see if I'm stretched. If I'm stretched, I'm not gonna go over 1 and then up or down 1. So for this one, from my center point, I go over 1, down 1. That's not stretched. It would have to go over 1, down 2, or over 1, down 1/2. Something like that would stretch or compress me. Inside my x grouping has to be opposite. So here it's a 1, here it's a -1. After the x grouping, I have a 2. What you see is what you get. It's still going to be a 2. So if you identify this point, the way that they fit into your equation is in the same order. The 3 goes first, the 1 goes second. The 1 goes first, the 2 goes second. They'll be in the same order. For G, what is my starting point? -5, 5. So my equation, this one is a negative, so I don't want to forget that. It's a square root. And the x goes underneath the radical. So is this one stretched or compressed? That sounds fun outside. It's Valentine's Day. What do you think it's like over a girl?
No.
No? No? She wants in. All right. For this next one, we are reflected. So there's a negative out front, but am I stretched or compressed? I went over 1, down 1. Is that any kind of stretch or compress? No. The move 1, 1, no. So then I can plug in my starting point. So inside the X grouping, it has to be opposite. Outside the X grouping, what you see is what you get. Let's take a little brain break. So this is student supplied emoji Pictionary. Again, you do not have to do emoji Pictionary. It can really be anything for a brain break. So this is the category of TV shows. Some of these I'm not familiar with, some of them I am. So let's see how you do. So this is somebody your age making these, so I assume these are something somebody your age may watch. I don't know. Vampire Diaries. Very good.
Grey's Anatomy.
Grey's Anatomy. I suppose it could be either one, but it was her. Her answers said Grey's Anatomy. Walking Dead. So this one I think is probably hard to show a symbol for them. It's definitely on the water, but I don't think they actually surf. Outer Banks. They don't surf, right? I don't feel like they ever surf, do they? They're, yeah. I've never seen this, so I don't know the relevance. Do you understand the relevance of this? Yeah. I don't understand the UM part. So I'm not sure. But both my classes, somebody's been able to guess it, so I don't know.
Oh wait, isn't that one where it's like the acid rain and then it looks like the bunker?
Yep, there's some good clues in there. It's in there, the 100. Why there's a 100. I've never seen this.
We have seen this.
Bridgerton? I've never seen it, so I don't know.
What is that? You know what?
Eyes on me.
What is it?
So I think some of these could be different things. I'm just going by students' answers. Oops. I went too far. This one is Criminal Minds. So again, remember, you too can come up with a brain break. It does not have to be emoji Pictionary. It can be really anything you want, just to give us a little break. On to the back. On to the back. The first section is all in words. Nobody really likes doing words in math, but we can do it. The first one says we've got a parent function, and then it says it's stretched vertically, shifted right, and shifted down. Okay, to write an equation, we can get going with, we know it's going to be an f of x. We know it's going to be a square root, and we know where the x is. So now we just fill in the 3 spots that there might be transformations. So as I read through, stretch vertically by 3, where does that go? It can either go in front with the X grouping or at the end. I think I heard somebody say it. Where does it go? In the front. So in the front, we put a 3. Shifted right 2 units. Where does that go? In the X grouping. And what do we put? says right, so we got to go opposite of +3 or +2. We have to go -2 because it's opposite. And then down 1 unit. So what you see is what you get. Not always do you have something in those 3 spots. Sometimes there's nothing there. If it doesn't shift that direction, then it doesn't shift. The next one, it tells you the parent function. Yes. Shifted right 2 units. The next one is a cubic. So that means that we could have something in front. We could have something inside. We could have something at the end. Reflected over the x-axis. What does that mean? Negative out in front. And shifted up 5 units. Where do we put that? At the outside, at the end. So +5. So nothing goes in the X grouping. So I could scoot that stuff over. Nothing even goes inside there. C, we know what the parent, actually C and D, I'm going to do these up on the board. You do them on your paper. I'm going to take attendance and then I'm going to do it. Give yourself a chance to try them. Part D should say over the x-axis. So you can change that to the x-axis. We're not going to do reflections over the y-axis. Did you get the same thing as me? Again, we're not going to do reflections over y, so change D to say x. So you might be given an equation and you've got to give me the description verbally, or I might verbally give you a description and you've got to give me an equation. We should be able to go either direction. And last, we are going to graph. So when we graph these, we need to know a few things. First thing we ought to be able to do is figure out that basic shape. For question number 4, it's going to have that basic shape and it's positive. For C, I'm just noting that that one is a negative and it's cubic, so it has to face down. I notice that this tells me that there is a stretch. And then what is that point going to be, the starting point? For A, what's that starting point? -5, +1. So I have everything I need to know to start my graph. I have a starting point. So I'm going to go to -5, +1, and I'm going to put a point. Okay, from there, I normally go, my first perfect square is over 1 and then up 1, but I'm going to double it. So I'm going to go up 2. The next one, my next perfect square would be moving over 4. Sorry, yes, over 4. 1, 2, 3, 4. And then 4, square root of 4 is 2, but I'm not going to go up 2. I'm going to double it. So how far up do I go? 4. So the next one, my next perfect square would be moving over 9. So if I moved over 9, so that's 5, 6, 7, 8, 9. And so the square root of 9 would be 3. So I would go 1, 2, 3, but I'm going to double it. So I'm going to go up 6, 3, 4, 5, 6. So if I connect my dots, yes. Five, 6, 7, 8, 9. So I think it has to go to the 4. This one? 1, 2, 3, 4. Ah, so it should be right there. Thanks. Thank you. So over 4. So does everybody see how this one is stretched vertically? Like it's goes up higher, it's stretched vertically. That's what that means. That 2 makes it stretch vertically. So we have a graph, it's beautiful. We just need to identify the domain and the range. So for this one, I need to figure out in the X direction, my graph starts at -5 and then it continues, it's bigger than -5. So I would say X is bigger than or equal to -5. That's my domain. For my range, that's in the Y direction. My Y's start at 1 and then they're above 1. So Y is bigger than or equal to 1. That is my domain or range. Yes, you can use interval notation. I don't really care, but I feel like this is easier. My next graph, I need to figure out what is my center point. What is this center point going to be? Very good. -2, -4. So I can go plot that point. -2, -4. So from my center point, I know that I'm gonna be in a negative direction. I already gave myself a hint. My graph needs to go down. So I am going to, yes. I don't know why it's -2. I don't know. It's not. That's why. Why is that what somebody told me and I wrote it down? Here's the reason why. You were looking at B. We're doing C. I meant to mention that to y'all. On C. Thank you guys. On C. Thank you, Adrian. How am I moving for C? What's my center point going to be? Not -1. It's what you see is what you get. It's going to be positive. 0. So I'm going to go plot that point. 0, 1. So up here. And then my graph tells me, or I know the shape, it's going to go down. So when I go over 1, and I'm not stretching, what is 1 times 1 times 1? 1. So I move in a direction of 1, but I got to move down 1. And then when I go over 2, what's 2 times 2 times 2? 8. So I got to go down 8. So it's exactly right there. Can't go any further. To the left, it's going to be symmetric. So when I go over 1, I go up 1. And then my other point would be somewhere up here. I'm going to connect the dots and make sure that they look as curvy as possible. So you need to be as curvy as possible. I know it's really hard with these graphs. Guess what? What do we know about odd functions? What do we know about their domain and their range? How far up and down do I go? All real numbers. How far left and right do I go? All real numbers. So when you are doing a cubic, easy peasy. All real numbers for both. Goes up forever, goes down forever, goes left forever, goes right forever. It's all real numbers for both of them. I had some of you that were really struggling on maybe it was the test, that you were confused by that symbol. That symbol is not the same thing as IR. That is not all real numbers. That is not correct. The symbol is an R. To make that symbol, you just do 2 double lines, and then I'll do that again. 2 double lines, and then you connect the left one to the right one. It's just an R with 2 lines. It is not an IR. Okay, you don't have to even make a fancy cursive looking R. It's just an R. So I would like for you guys to try B and D. I'm going to pass back some papers. I want you guys to try B and D. You have a pencil, so use a pencil. Because if you need to, you can erase. But try B and D. Ella had the correct center point for B. So try B and D. You don't know if you know how to do these unless you try them. There are questions on your quiz. You've got to try it.
Yes. Yes.
Okay, so you got a good shape going. Good job. Listen. And then. You're good. You're ready for your step point. So what's that look like to me? What's the parentheses or so last number is always the number you see. Yes. Except for it's a negative, so it has to go. So the negative is for root graph. So positive or negative is for root graph, that's negative. So we are moving like we're so parent you're right. So nine and
You? You don't get me down. Somebody thinking of this. Yeah, so if you're like inside the line, it's their box, or their nothing. This one thing is if it's outside, this one's the door space, it was standing before and yeah. This is a zero basically. That's why it's a zero one.
I need to go over nine. And the next day,
The issue about how it's the problem.
I don't know, we were talking about.
And
So for this one. Two. Oh, yeah. 2 is 8. There, you guys ready for me to kind of go over? Most of you guys have started, and that's awesome. Even if you start and you get stuck, that's what I need on the quiz. I need you guys to at least start, even if you get stuck. So for B, first thing I notice, we have a negative. So when I'm negative, I need to remember that that basic shape needs to go like that. My point for this one has to be opposite inside the grouping. So -2, -4. I know my starting point is at -2, -4. Ella was right. We were just on the wrong problem. So from here, my starting point. I know that it's going to have this shape. I'm not stretching or anything. So I have to think of those perfect square movements, things that can be a perfect square root. So I have 1 is a perfect square root. I have 4 is a perfect square root. I have 9 is a perfect square root. And so we have to think about what those are. So that's how I figure out my movements. So 1 is a perfect square root. So I go over 1. Square root of 1 is 1. So I put a point. But I'm going down. So wrong direction. Oops. I'll erase that one. So my next perfect square would be a 4. So that means from my starting point, not from 0, 0, from my starting point, I can go over 4, 1, 2, 3, 4. And the square root of 4 is 2. So that means that I go down 2 and put a point. And as you're doing these, they should follow that shape. If they're not kind of following that shape, you're doing something wrong. And then my next perfect square would be a 9. So I'd have to go over 9. Well, that's 2 and then 7. 7, 8, 9. So that's exactly 9. Square root of 9 is 3. So I would go down 3. If it was a positive graph, you make the same movements, you just go up. So now I can connect my dots. Remember that it is half of a U. That is that shape. It is half of a U, so it's not a straight line. It is half of a U. So you want to make sure that you're as curvy as possible. For this one, I don't go on forever left and right or up or down. So we have to figure out, we've got X goes with domain and range goes with Y. We start with that. For my domain, I start at, and you look at the x-axis, I start at -2 and my graph goes on forever that direction. So my X is bigger than or equal to -2. For the Y's, I go look along the Y-axis. Where does my graph start? It starts at -4. My graph is below -4. So since it's below, it has to be negative or less than or equal to. That is my domain or my range. For D, I know that that is a cubic function and it's positive. So the shape, what it's going to look like is that's a positive cubic function. I don't have to graph it to identify the domain and range. What are they? All real numbers. Get that right. They're both all real numbers. What is my starting point for this one? Good job. So remember, they're always, your point is always going to be in the same order you see the numbers. First you see a 2, then you see a 4. They have to go in that order. And then anything in the X grouping is opposite. So you've got a 1 and you've got a 3. They go in that order. Anything with the X grouping is opposite. So it has to be positive. And then the K, what you see is what you get. So I'm going to go plot that point at 1 and then -3. So for a cubic, what I'm doing to the X is that I'm cubing it. So I go over 1 and it's positive. So I know I need to go up. So I go over 1. 1 times 1 times 1 is 1. For both of these, whether you're doing a square root graph or if you're doing a cubic graph, your first point is just over 1, up 1, unless you're negative. It's over 1, down 1. Unless you're stretching, it's always over 1, up 1. For my second point, from my center, not from 0, 0, from my center, if I move over 2, 2 times 2 times 2 is what? It's the same every time. 2 times 2 times 2 is what? 8. So I go up 8. I'm going up 3, 4, 5, 6, 7, 8. Okay, so it will work. So I go up to 5 and put a point. So I can connect the dots at symmetry. So it's going to go the same in the opposite direction, but down. So I can go over 1, down 1. And I don't know where my next point is, but it's going to be somewhere down here. You need to know that it is somewhere way down here. So you cannot cross this line. You can't just go down like that. Like it can't be way over here. It has to go like straight down. When I connect my dots, I'm going to be as curvy as possible. I know it's hard, but you can kind of start with just that center point and kind of curve this way and curve this way. Just make it curvy straight at the middle. And then you can kind of go straight up to get to your next point. And this one goes pretty much straight down. Okie dokie, you don't have a lot of time, but you do have some time. So you can get started on your assignment.